So we've been analyzing parts of graphs for a while this year, but now we're doing rational functions. And since we have rational functions, these graphs look a little different than we're used to. So they're usually going to be in like 2 or 3, sometimes more pieces. So it kind of looks like there's 2 separate graphs, but this is all one function. This middle graph is all one function. This graph on the right is all one function, even though it looks like it's split up. All right, so we can find these pieces here by using these graphs. Our VA stands for vertical asymptote. So we're looking at any of those lines. The graph is not touching. It's just very close to. So in this first one, we see that this line here at -3 appears to be a vertical asymptote. But vertical asymptotes are always written as equations. So if you just wrote -3, that doesn't tell us what the vertical asymptote is. You need to make sure to write x equals -3. That's telling us that line right there. If we work our way across, our vertical asymptotes in the middle one looks to be right about here at x equals -1. And we actually have 2 here at x equals +1. So we've got 2 vertical asymptotes on the middle graph. And then if we look at the last graph, looks like we've got a vertical asymptote right about here at x equals 2. So now we're looking at horizontal asymptotes, which means they go from left to right, sideways. And it's the same idea. It's a value where the graph is flattening out. And so if we look at this first graph, it looks to be flattening out around the value of 1. But again, that's not a full answer because it should be an equation. So our horizontal asymptotes are always in the form y equals. So make sure you write y equals 1. In this middle graph, we see it flattening at 0 on the 2 ends, but then it's kind of weird because it's crossing through 0 in the middle. So this is where we learned that y equals 0 is a horizontal asymptote, and it's okay for a curve to cross a horizontal asymptote. But it is never okay for it to cross a vertical asymptote, so we will never see that happen. If we look at this last graph, it looks like the horizontal asymptote is right here at the value y equals 2. Okay, so increasing and decreasing talks about the roller coasters. So when we go, I'm gonna make this note here, increasing and decreasing, always read from left to right, and we always use the x values. So from left to right, what are we doing on the roller coaster? If I draw this little guy on the roller coaster, he's going to be going up, so he's going to be increasing. And the same thing would be happening on this bottom curve. So there's no decreasing there. If we look at the middle picture, I can draw my roller coaster guy again if that helps me. And it looks like he's going down the hill. And the same thing happens if I draw him on each of the pieces of this function. So it's going to be the same for each. So he's decreasing here, not increasing. And then on my last graph, it looks like we also have decreasing and not increasing. So now that I've figured that out, I'm going to go back and write my intervals. So the increasing and decreasing is going to be very similar to the domain because it's helping us see the x values. So it's going to be very similar. So if we start out at the left side, this is continuing to the left forever. So that would be -infinity. And it continues until we run into this green vertical asymptote. We called those walls, or we talked about like if you walk into a door or something, like a closed door or a wall or a glass screen door. It's very embarrassing and funny, but you can't pass through the wall, right? So those vertical asymptotes are those stopping points. So our increasing interval stops at -3, but then it picks back up on this side of -3 and continues all the way out to +infinity. So if we look at the middle graph, since there's 3 pieces of the curve, there's going to be 3 pieces of this decreasing interval. So again, it starts all the way out here at negative infinity, and we come across until we hit this first vertical asymptote at -1. So negative infinity to -1. We pick back up at -1, and we go just a little bit until we hit this other vertical asymptote at +1. And then we pick back up at +1 on this side, and the curve goes out to the right forever to positive infinity. Whew, okay, last one. Again, curves going out to the left forever, so negative infinity. I'm looking at these x values, so I like to trace along my x, and boop, there's the wall. I ran into this vertical asymptote at 2, so I close off my interval. I pick back up on the other side of the vertical asymptote up here. So 2, and then I continue over, and I notice this curve is going over to positive infinity. So 2 to positive infinity. All right, last but not least, the zeros. We didn't focus on those a ton this unit, but that's just telling us those x-intercepts. So the zeros, we can see here, we've got one x-intercept at x equals -2, or we could write it as the point -2, 0. In this middle graph, it looks like we've just got one x-intercept at 0, 0. So the x value is 0 there. And then on the last one, looks like it's kind of in the middle of 0 and 1/2. I mean 0 and 1, so I'm going to call it 1/2. 0, or we can just write the x value is 1/2. Great job, everyone.